Welcome back. So, this week we are going to be talking about the relationships between numbers, how to show those relationships, including graphing equations. I love this part, it's super fun. So, we are using our workbook starting on page 233. And here we go. So, the table below shows how many candles are in different numbers of boxes. Find a pattern that explains the relationship between the values of C and B. So C stands for the number of candles, and B stands for the number of boxes. And when it says relationship, it's that whole thing of like looking for a pattern. Like, if C is this, B is this, and what is that pattern? So find a pattern that explains the relationship. Use words and numbers to describe the pattern. How many candles will there be in 10 boxes? In 10 boxes. So let's take a look. If the number of candles is 8, there are 2 boxes. If the number of candles is 12, there are 3 boxes. If the number of candles is 16, there are 4 boxes. So when I've got 3 examples there, I can sort of take a close look at it and see what the pattern is. What's the rule? So 8 and 2, well, if there's 2 boxes and there's 8 candles, then that means there's 4 candles in each box. But let me test it out with these other things, because it also could be like, I don't know, -6, I don't know. This one is 12 and this is 3 boxes. Does that hold true with the pattern? It does. And 16 and 4, yep, it holds true. So that means that there are 4 candles in every box. Or you could say C divided by B equals 4, or C divided by 4 equals 4. There are 4 candles in each box, so there will be 40 candles in 10 boxes. Okay? And then, how about this one? Use structure. Write a rule that explains how you get from the values in the right column of the table above to the values in the left column. And what do? You multiply B by 4 to get C. Okay? All right, let's look at the next page, 234. So here we've got the Slide and Splash Water Park and this very happy gentleman. Find a pattern to write an equation. Okay, so the table shows the cost of weekend tickets to the Slide and Splash Water Park. Find a pattern that relates the number of tickets, N, and the cost, C, of the tickets. How much would 6 tickets cost? So let's take a look at this table. 3 tickets would cost $16.50. 4 tickets would cost $22. 5 tickets would cost $27.50. So what is the pattern? Well, I went back and I divided the total cost by the number of tickets for each of these just to make sure it stayed consistent. And I found that each ticket cost $5.50. So it wants to know how much do 6 tickets cost? 6 times 550. What's 6 times 550? Let's see. $33. Okay, so let's look down here. Look for a pattern in the table that relates C, which is the dependent variable, and N, the independent variable. 3 times 550 is $16.50. 4 times 550 is $22. 5 times 550 is $27.50. Then write an equation to describe the relationship. So 5.5 times the value of n equals the value of c. So 5.5n equals c. Or you could say c equals 5.5n. This is the equation that shows the pattern that you figured out. Then find the cost of 6 tickets, and we did that already. The cost of 6 tickets is $33. All right, say it with me. Try it. Okay, the table shows the number of yards, y, that a professional bicyclist rides in s seconds. Find a pattern that relates the variables. If the cyclist maintains this speed, how far would the cyclist ride in 8 seconds? Okay, let's look at the table. In 2 seconds, the bicyclist can ride 24.4 yards. In 3 seconds, they can ride 36 6/10 yards. In 5 seconds, they can ride 61 yards. And in 6 seconds, they can ride 73 2/10 of a yard. All right, so what are you noticing about this? I think the easiest thing to do is just start here, divide 24 4/10 by 2, and you'd get 12.2, right? So what that tells you is that for every 1 second, they travel 12 2/10 of a yard. Okay, so find that's the pattern. If the cyclist maintains that speed, how far would it travel in 8 seconds? Well, 8 times 12.2 is 97.6. So that's how far they would travel in 8 seconds. What's the equation that shows that relationship? 12.2s equals y. Because 12.2 times the number of seconds equals the number of yards. Okay? Very, very short bicycle rides. Okay, let's look at the next page. On 235, we have Ethan, who owes his mother $75. He repays his mother a set amount each week. How much will Ethan owe his mother after 12 weeks? Make a table and look for a pattern that relates the variables. Okay, so here's what he did. Week 0, he owes $75. Week 1, it's 75 minus 5 times 1, which is 5, and now he owes $70. Week 2, 75 minus 5 times 2, he owes $65. So we see that he's paying $5 each week, and so it's reducing the amount owed by $5 each week. So this 5 represents the number of dollars he's paying, and the 1, 2, 3, and 4 is the week that he's on. So this is the amount that he's going to have left. So we got up to 4 weeks here. We want to know, well, how much is he going to owe after 12 weeks? So how can we put that into an equation? Think about that for a minute. And then as you look down here, it says write an equation to describe that relationship. So we're going to use A for the amount that is still owed. $75 was the loan amount to begin with, minus the amount paid after 5 weeks. So 5 is for $5 or for 5 weeks, and 5 is for $5, and W is the number of weeks that he's been paying. So let's see. The equation then is A equals 75 minus 5W. Now, find how much Ethan will owe after 12 weeks. Well, A equals 75 minus 5W. A equals 75 minus 5 times 12. Or A equals 75 minus 60, which means that A equals 15. So we started off up here. We substituted 12 in for the W because that's how many weeks. And then we simplified that and said A equals 75 minus 5 times 12, which is 60. So A equals 15. Ethan will owe $15 after 12 weeks. All right? Okay, say it with me. Try it. If Ethan continues to pay $5 per week, how many more weeks will he need to pay his mother after 12 weeks? He still owes $15. Okay. 3 weeks. He still owes $15, paying $5 per week. 3 times 5 equals 15. Okay? All right. Let's take a look at the last page for today, page 236. And the key concept on page 236 is that you can use patterns in a table to write an equation that relates the independent and dependent variables. Okay, let's take a look at this table. The values for J are 1, 4, 7, 8, and 9. Okay, and then M, it's 3, 12, 21, 24, 27. Now let's see how J and M relate to each other. 1 and 3, 4 and 12, 7 and 21, 8 and 24, 9 and 27. Okay, M is 3 times J. If I were going to write that in an equation, I would say M equals 3J. That's the pattern, and that's the equation to show that pattern. Do you see that? M is 3 times 1. 12 is 3 times 4. 21 is 3 times 7. So M equals 3J. All right, let's take a look at the do you understand questions. I'll talk you through them a little bit, then you can pause the video and answer them and come back and check your answers. How can you use a pattern to write and solve an equation? Just think about what we've been doing so far. How have we been using a pattern to write and solve an equation? What have we been doing? Okay, make sense and persevere. How do you find a pattern that relates the values in a table? So, for example, when you look at this table up here, what did you do to figure out what the pattern was? That's what they're asking you to write there. Reasoning. In example 2, what happens to the value of the dependent variable? A, the amount still owed, when the value of the independent variable, that's W, the number of weeks, Ethan pays $5, is increased by 1. That's kind of a mouthful. So if you increased the amount that Ethan paid from $5 to $6, what happens to the dependent variable or the amount still owed? Okay. And this one, look for relationships. Use the pattern in the table below to write an equation, just like we did up here at the top. So pause the video, answer those questions, and start it up again when you're ready. Okay, so to use the pattern to write and solve an equation, figure out what changes each time and by how much. So that's how you kind of analyze the pattern and figure it out. You may have said it in a different way. That's okay. That's the way I express it. So for this one, look for the same type of changes and make sure they are consistent. So for example, with this one again, this is 3 and this is 1, 12 and 4, 21 and 7, and so forth. It's changing by the same amount each time. In every one of these examples, M is 3 times J. If you had something different where all of a sudden, instead of 4, this said 2, well, that would be different because 2 is not, you have to multiply that by 6 to get 12, so the pattern doesn't stay the same. So I'd have to go back and rethink things to figure out what the pattern actually was. So that's what I mean by making sure they are consistent, making sure they don't change. Okay, for reasoning, the value decreases by 5 because it's $5 per week, right? So if you changed that to 6, it would change by $6 a week instead of 5. And then finally, look for relationships. Use the pattern in the table below to write an equation. So I'm looking at this 1 and 7. I mean, if I only look at the first one, it looks like the rule is add 6. But when I look at the second one, 2 and 12, well, that pattern doesn't hold anymore. So it's got to be something different. So I have to look at all of the examples. And then what I find is, if I say 5 times 1 plus 2 equals 7. 5 plus 2 equals 7. Okay, that works. Let's see if it works for the next one. 5 times 2 is 10, plus 2 is 12. 5 times 3 is 15, plus 2 is 17. 5 times 4 plus 2 is 22. So y equals 5x plus 2. That's my equation. That's the pattern from that table. All right, let's take a look at the other side of the page. The table shows Brenda's age, B, when Talia's age, T, is 7, 9, and 10. Find the pattern and then write a rule and an equation that represents the pattern. Then find Brenda's age when Talia is 12. I mean, why can't you just ask Brenda how old she is? Oh, well. Anyway, let's take a look at this table, see what kind of a pattern we can notice. So when Talia is 7, Brenda is 2. So she's 5 years younger. Let's see, does it hold? It should, right? When Talia is 9, Brenda is 4. Okay, it's minus 5 again. When Talia is 10, Brenda is 5. So it's holding up. Now, let's look at this one. In 6 and 7, use the table below. Use this table for both of these questions. You've got the table 4 and 1, 5 and 3, 6 and 5, 7 and blank, should it be? 8, what should it be? And then it says use the equation y equals 2x minus 7 to complete the table. Y equals 2x plus 7. Let's see if that works with the numbers that we know about. Y equals 2 times x minus 7. Okay, so 2 times x, that would be 8, minus 7 is 1. Ah, that works. Let's take a look at this. 2 times x is 10, minus 7 is 3. Okay, it's working. 2 times 6 is 12, minus 7 is 5. Okay, so then how can you use that to complete that table? Then state the rule for the pattern in words. So here's an equation. What's the rule? It's kind of like the equation or the pattern, but written in words instead of as an equation. So complete those. Pause the video here and then start it up again when you're ready to check your answers. Ta-da! Okay, so the equation is b equals t minus 5, right? And that holds true the whole time. And so if b equals t minus 5, then b for this will be 12 minus 5, meaning that when Talia is 12, Brenda is 7. Okay, for 6 and 7, here's how you should have completed that table. This should be 7, and this should be 9. And if you plug it into the equation, you can see that it works. 2 times x, that's 14, minus 7 is 7. 2 times 8 is 16, minus 7 is 9. All right? And then if you're going to put that into words, you would say y equals 2 times x minus 7. All right? That's it. Okay, so we will talk more about the relationship between numbers and how to use tables and equations, and eventually by the end of the week, graphs. So I will see you next time. Good work. Bye.